Dear friends, I myself, Dr. Bharat Parab, discussing the topic zeros of a polynomials. There are two terminologies as one zero polynomial and second zeros of a polynomials. They sound same, but there is vast difference between these two terminologies. Okay, so we'll see one by one, and we will know the meaning of these two. Okay, so first one, zero polynomials means zero, which is also considered as a polynomial. Okay, that is 0 is equal to 0 into x raised to n. Okay, that is equal to 0. So where n is equal to any whole number. Got it? So as this can attain any number, therefore degree of a zero polynomial is not defined. Okay, got it? And second one, zeros of a polynomials. Okay, it's not zero only, it is zeros, maybe more than one value. Okay, so we will see this later on. Initially we see the meaning of this. Second one, zero or root of a polynomials means at some value of x its value is zero. Okay, these values of x are called as zeros or root of a polynomial. Got it? So polynomial gets value 0 at some value of variable or x or unknown, whatever it may be. Okay, at some value of x, polynomial value is 0. This value of x is called as zeros of a polynomial or zero of a polynomial if it is only one. There may be more than one. Okay, we will come to know about this in further part of this video. Okay, consider the following expression: px is equal to 4x cube minus 3x square plus 3x minus 2. Okay, now we will try to see the value of this expression or this polynomial at different values of x. Okay, so we will substitute this for x equal to 1. Okay, so if you take x equal to 1, then p1, we have to replace this x also by 1. So I'm writing it like this, so that is very easy to substitute the value. Okay, this is same, just copied it down. So substitute it here. 4 into 1 cube minus 3 into 1 square plus 3 into 1 minus 2. If you solve this, you get 4 minus 3 plus 3 minus 2. This 3 cancels and 4 minus 2 is 2. This is the value of the polynomial at x equal to 1. Okay. Now we will check for x equal to minus 1. Then p minus 1 is equal to 4x cube. Again, this is n copied and need not read this. And just I can jump it here, equal to 4 into minus 1 cube minus 3 into minus 1 square plus 3 into minus 1 minus 2. If you solve this, you get 4 into minus 1 minus 3 into 1. This square is 1. Okay, so 3 into minus 1 minus 2. So minus 4 minus 3 minus 3 minus 2 is minus 12. So at x equal to minus 1, the polynomial has a value minus 12, and at x equal to 0, all these will be zeros and you get minus 2. Very simple. Okay, so we are just checking the value of this polynomial at different values of x. Okay, now see another example: qy equal to y minus 1. Now at y equal to 0, okay, q0 is 0 minus 1 is minus 1. Okay, and at y equal to 1, q1 is 1 minus 1 is 0. Okay, so as q1 is equal to 0, 1 is 0 of qy, which is y minus 1. Got it? This 1 is the value of y at which expression is 0. Okay, so this 1 is called as 0 of this polynomial. Okay, that means its value of variable at which the polynomial is 0 is called as 0 or root of a polynomial. Okay, here we are concerned with the value of variable, in this case 1. So 1 is called 0 of this particular polynomial. Got the meaning of this? Okay, here for all three values we cannot find the value of this is 0. There may be some value of x, maybe in fraction, we have not checked. Okay, we have just checked some easy values. Okay, here we have found out the value of y at which this is 0. Okay, so you must have got idea about 0 or root of a polynomial. Okay, this is very important quote. Okay, try to understand this. I have made it simple for you. Consider the following expression: px equal to 4 equal to, that this can be written as 4 into x raised to 0. Okay, now see, we have x raised to 0. Okay, at any value of x, okay, not 0 except 0. Okay, not equal to 0, x cannot be 0. Okay, so for any value of x, the value of this px, that is equal to 4 into x raised to 0, can never become 0. Got it? If it is 1 or 2 or 3, this x raised to 0 will be 1. Even minus values, this will be 1. Okay, so the value of this will be 4 into 1 is 4. Okay, so as value of this cannot become 0, so this does not have any 0. Okay, what does this mean? We have seen this. Hence, non-zero constant polynomial has no 0. We are talking about the zeros of a polynomial. Okay, now see, this is very important. But if we consider the polynomial 0, okay, here it was 4. This is also a polynomial. See, we have seen this. Now there is another polynomial 0. It's called as, this is 0 polynomial, and we are talking about the 0 of the polynomial. Okay, now if we consider the polynomial 0, which we can also call as 0 polynomial, I was talking about this. Okay, and try to find the 0, then we can multiply by any number to get 0. This 0 can be multiplied by any number. Okay, and we get 0. Okay, then hence every real number is a 0 of the 0 polynomial. Okay, we are talking about 0 polynomial and 0 of the polynomial. Okay, so every real number is the 0 of the polynomial. Try to understand this. Okay, still if you face any problem, try to contact me or give me in the comment section, and I will again explain this. Okay, so from this we tabulate the observations as 1. A 0 of a polynomial need not be 0. Okay, 0 of a polynomial need not be 0. 0 may be a 0 of a polynomial. This 0 is 0 of a polynomial because 0 into 0 is 0. Okay, every linear polynomial has one and only one 0. Simple. And fourth one, a polynomial may have more than one 0. Now this seems to be two contradictory statements. Okay, but they are not. Just read this comment. In fact, this depends upon that 0 depends upon the power of the variable, as variable can have as many values as power of the variable. Okay, we have seen is x cube, then we will have, see this is over there. Linear has 1, quadratic has 2, cubic may have 3, etc. Okay, so after learning this theory, we will try to solve some exercise. Okay. So now exercise first one, find the value of the polynomial 5x minus 4x square plus 3 at x equal to 0. First one. Second one is x equal to minus 1, and third one is x equal to 2. Answer, x equal to 0. So writing px equal to 5x minus 4x square plus 3. I'm writing the whole expression as it is, or polynomial, and that is equal to p0 because x equal to 0. So we have to substitute x by 0. So p0 equal to 5 into 0 minus 4 into 0 plus 3. So this is plus 3. Now x equal to minus 1. So writing all this as it is, you have to write it because it is very easy to substitute then. Okay, p of minus 1 is equal to 5 into minus 1 minus 4 into minus 1 square plus 3. If you solve this, minus 5, this is 1, so minus 4 plus 3 is minus 6. Okay, and third one, x equal to 2. So 3 here it is same. Okay, now p2 is 5 into 2 minus 4 into 2 square plus 3. So this is 10 minus 4 into 4 and plus 3, that is 10 minus 16 plus 3 is minus 3. Okay, very simple. Okay, second one, find p0, p1 and p2 of each of the following polynomials. Okay, there are many. First one, py equal to y square minus y plus 1. When it is y here, you have to have an expression in y. When it is 0 here, when y equal to 0, so replace all these y's by 0. Okay, so p0 is, writing the expression, 0 square minus 0 plus 1 is 1. p1 is 1 square minus 1 plus 1 is 1 minus 1 plus 1 is 1. And p2 is here 2 square minus 2 plus 1 is 4 minus 2 plus 1 is 3. Very simple. Okay. Exercise continued. Second one, first we have seen, this is the second one, to find out p0, p1 and p2 for the polynomials. Second one, pt is equal to 2 plus t plus 2t square minus t cube. Answer, p0, you, we have to substitute 0 at the place of t. So this 2 remains. So p0 is where t equal to 0. p0 is 2 plus t plus, this is the expression we have copied out. Okay, so 2 plus 0 plus 2 into 0 square minus 0 cube, that is 2. Okay, p1, so substitute 1 at the place of t, is copied down here. 2 plus 1 plus 2 into 1 square minus 1 cube. If you solve this, you get 2 plus 1 plus 2 minus 1 is 4. This 1 cancels, you get 4. p2 is equal to, see here, 2 plus 2 plus 2 into 2 square minus 2 cube. So if we solve this, 2 plus 2 plus 2 into 4 minus 8 is 8 cancels, you get 4. Okay, so this is second one. Third one, a simple one, px equal to x cube, and we have to find out p0, p1 and p2. So p0 is for at x equal to 0. Okay, so it is here. Yes, p0 is x cube is 0, cube is 0. Here x equal to 1, so p1 is x cube equal to 1 cube equal to 1. And for p2, where x equal to 2, is x cube, that is 2 cube, that is equal to 8. That is a value of px at x equal to 2, 1 and 0. Okay, exercise continued. We have so far seen 3 in this. This is the fourth one in the second one. Okay, second exercise, find p0, p1 and p2 for each of the following polynomials in this. This is fourth one. Okay, So px equal to x minus 1 in one bracket and x plus 1 in another bracket. We have to find p0 first. Answer p0 where x equal to 0. Px we write down the whole expression as it is just for simplification. Okay, px equal to x minus 1 into x plus 1. So p0 is equal to c. We have to substitute 0 for this x, the 0 minus 1 and 0 plus 1. So minus 1 into plus 1 is minus 1. Okay, p1 and x equal to 1. So we write it like this. P1 is 1 minus 1 and 1 plus 1. The 0 into 2 is 0. And P2 at x equal to 2 is, if you substitute 2 for x, 2 minus 1 and 2 plus 1. So this is 1 into 3 is 3. Very simple. Okay. Exercise continued. Third one, verify whether the following are zeros of the polynomial indicated against them. Okay, what's the meaning of this? We'll get it clear from this example. Okay, first one, px is equal to 3x plus 1 and value of x given is x is equal to minus 1 upon 3. Okay, so we have to check the value of this polynomial at the given value. Okay, and check whether the polynomial gets 0 at this value. Okay, we will see this, and if that is so, then this is the 0 of the polynomial. Okay, we have seen this. So we will continue with the answer. Px is equal to 3x plus 1 and x is equal to minus 1 upon 3. So substitute x is equal to minus 1 upon 3 in px. So we have done it here. P of minus 1 upon 3 is equal to 3 into minus 1 upon 3 plus 1. Okay, so 3 cancels, you get minus 1 plus 1 is 0. Yes, value of the polynomial is 0 at x equal to minus 1 upon 3. Hence, or therefore, minus 1 upon 3 is 0 of px. That is what we have to find out. Okay. Second one, now it is very simple. Px equal to 5x minus pi and value of x given as 4 upon 5. So answer px equal to 5x minus pi. So we have to substitute x equal to 4 upon 5 in px. So we have done it here. P of 4 upon 5, that is equal to 5 into this x 4 upon 5 minus pi. Okay, so 5 cancels, you get 4 minus pi is not equal to 0. Okay, therefore 4 upon 5 is not the 0 of px, of this px. Okay, and that is what you have to find out. Okay, so these are very simple problems. You can try to solve it yourself first and then check for this video. Okay, so the third one, px equal to x square minus 1 at x equal to 1 and x equal to minus 1. Answer, writing the whole expression again. Okay, now substitute x equal to 1 in px. So we have done it here. P1, so writing it again, x square minus 1. We are substituting the value of x, that is 1. 1 square minus 1 or 1 minus 1 is 0. Value of the expression or polynomial is 0. Hence, 1 is the 0 of px. Got it? Now substitute x equal to minus 1 in px. We have done it here. P of minus 1 equal to x square minus 1, that is equal to minus 1 square minus 1. Okay, that is solve this is 1 minus 1 is again 0. So minus 1 is also the 0 of px. Hence 1 and minus 1 both are the zeros of px. That is expected as the degree of this polynomial is 2 and there is a possibility of 2 zeros. Okay. Now fourth one, px equal to x plus 1 in one bracket and x minus 2 in another bracket, and check the values for x equal to minus 1 and 2. Answer, write the whole expression again, and now substitute x equal to minus 1 in px. So we have done it here, p of minus 1. Before substituting, we have copied down the expression. Now at the place of x is minus 1 plus 1, and again minus 1 minus 2. So this is 0 into minus 3, that is 0. So we are doing for the second one, x equal to 2 in px. So p2 is equal to here 2 plus 1 and 2 minus 2. Okay, so this is 3 into 0 is again 0. Both the values we are getting 0. Hence minus 1 at this and 2 at this are the zeros of px. Okay, so it's become very simple now. Okay, fifth one, px equal to x square at x equal to 0. Answer, px equal to x square at x equal to 0. Write the whole expression again. Substitute x equal to 0 in px. So we have done it. P0 is equal to x square equal to 0 square is 0. So 0 is the 0 of px. Very simple. And sixth one, px equal to lx plus m, and value of x is equal to minus m upon l. Okay, so answer, that whole expression again and substitute x equal to minus m upon l in px. So we have done it. P of minus m upon l, that is equal to lx plus m, or l into minus m upon l plus m, that is equal to cancel this l and l, you get minus m plus m is equal to 0. So minus m upon l is the 0 of px for this. Okay, so seventh one, px equal to 3x square minus 1 at x equal to minus 1 upon root 3 and 2 upon root 3. Answer, write the whole expression again along with this, because this expression in exam will be on question paper. You need not look at the question paper again and again. So write it very correctly along with sign and in comma and everything. Okay, so you have done it. Now substitute x equal to minus 1 upon root 3 in px. We have done it here. We again copy this thing here. Okay, so p of minus 1 upon root 3 in 3x square minus 1 will be equal to 3 into, you will need a bigger bracket here because you will need this bracket at this place, minus 1 upon root 3 square minus 1. So if you solve this, we get 3 into 1 upon 3, root 3 will be 3. Okay, minus sign will go, minus 1, so it is 1 minus 1 is 0. As value is 0, see here, minus 1 upon root 3 is the 0 of px. Okay, okay, therefore minus 1 upon root 3 is the 0 of px. Substitute x equal to 2 upon root 3 in px. Same thing. Okay, p of 2 upon root 3, I'm writing it here again, and again big bracket. Okay, here 3 into 2 upon root 3 square, the whole square is much minus 1. So if you solve this, you get 4 here and 3 here. 3 cancels. Okay, you are left with 4 minus 1 is 3. It's not 0. Okay, so this is not the 0 of px. So as p of root or 2 upon root 3 is not equal to 0. Okay, 2 upon root 3 is not the 0 of px. Hence, minus 1 upon root 3 is 0 of px, but 2 upon root 3 is not 0 of px. Okay, we know this will have two values, as so square or degree of this expression is 2. Can you find the another value where this another 0 of the polynomial? Okay, it's very simple. Do it. Okay, and give me in comment section. Okay, and last one in this, px equal to 2x plus 1 at x equal to 1 upon 2. Answer, px equal to 2x plus 1 at x equal to 1 upon 2 or half. Substitute x equal to 1 upon 2 in px. So therefore p of half will be, I'm taking it directly. Okay, you should actually write it. Okay, do it. in exam so that you don't get confused. So 2 into substitute this half in place of x. Okay, so 1 upon 2 plus 1 is, you cancel this 2, 1 plus 1 is 2, is not 0. Okay, so p of 1 upon 2 is not equal to 0, hence 1 upon 2 is not the 0 of px. Got it? Very simple. Fourth one. Okay, this was the third one. It was having some 8 sub questions. Okay, fourth one for the exercise. Find the 0 of the polynomial in each of the following cases. Here we were given values and just were asked to find out whether this given value gives 0 or not. But here the problem is different. We have to find out the 0 of the polynomial. Okay, it's very simple. First one, px equal to x plus 5. Answer: to find the 0 of the polynomial, px should be equal to 0. So we have to directly make this 0, x plus 5 is 0. If you solve this, you get x equal to minus 5. Therefore, minus 5 is the 0 of px, which is equal to x plus 5. Okay, very simple. Second one, px equal to x minus 5. Answer: to find the 0 of the polynomial, px equal to 0 or x minus 5 is equal to 0. If you solve this, you get x equal to 5. Therefore, 5 is the 0 of px, which is equal to x plus 5. Very simple. Okay. Third one, px equal to 2x plus 5. Answer: to find the 0 of the polynomial, px has to be equal to 0. So 2x plus 5 is equal to 0, to make it 0. So transfer this 5 on the other side and it will be minus 5. So 2x equals minus 5. So x equal to minus 5 upon 2. Therefore, minus 5 upon 2. Remember, always sign plays important role. Okay. So minus 5 upon 2 is the 0 of px, which is equal to 2x plus 5. Okay. Fourth one, px equal to 3x minus 2. All these are very simple. Okay, that's why I told you solve it yourself and then try to look in this video. Okay, answer: to find the 0 of the polynomial, px is equal to 0. So 3x minus 2 is 0. So 3x equal to 2. This 2 goes on this side. The sign change. X equal to 2 upon 3. Therefore, 2 upon 3 is the 0 of px, which is 3x minus 2. Okay. Fifth one, px is 3x. Very simple. To find the 0 of the polynomial, px is to be 0. So if 3x has to be 0, x has to be 0. Therefore, 0 is the 0 of px, which is equal to 3x. Very simple. Okay. So the next one, px equal to ax, where a is not equal to 0. Answer: to find the 0 of the polynomial, px has to be equal to 0. So therefore, ax is equal to 0, and we are given a is not equal to 0. So x is equal to 0. To get this value 0, therefore 0 is the 0 of px, which is equal to x. Okay, very simple. And last one, yes, it is last one. Px equal to cx plus d, where c is not equal to 0, d is not equal to 0, and c and d are real numbers. Okay. Answer: to find the 0 of the polynomial, px has to be equal to 0. Therefore, cx plus d is equal to 0. This has to be equal to 0. So transfer this d on this side, sign will change. So cx equal to minus d or x equal to minus d upon c. Okay. Therefore, minus d upon c is the 0 of px, which is equal to cx plus d. Very simple. Okay. So do it. Okay, and make some practice or have some practice. Okay. This is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of zeros of a polynomials, let me know through comment section and I shall solve it. Please like, share and subscribe. Okay. Let all students be benefited by all these videos. Okay. Thanking you. Good luck.